name derivatives. Okay, that's what we will do. As I said in section 1.4, we talk about the tangent line, the velocity, at one point, the instantaneous rate of change. That means this will be the stuff that we will pull out now and talk a little bit more deeper. Okay? That means let's see what we have. I will switch off my camera as always. It's just better to focus on the screen. Okay. That means we did have a tangent line, the slope of the tangent line problem in section 1.4, and we know that the slope of the tangent line actually came from the slope of the secant line, right? Which we have to set up this situation that the coordinates of the additional point, we name the point Q, the x-coordinate, has to be extremely close to the point of the tangency, to the point P. Okay, that we remember this. And then we have teeny tiny interval, and based on that, we can draw a secant which is almost a tangent. Okay, that we did learn actually this, that the slope of the tangent line is the limiting position, the limit of the slope of the secant line. And we can nicely see the secant line has to be extremely close. Okay, and this is the definition. Okay? We did name the limit of course we're confident with the limits notation, but the tangent line to the curve f of x at the point A, and f of A is the line through P with that slope, and this will be the slope. And we can see this is simply the slope of the secant, and indicating the limits, okay? That x approaches A. The coordinates of the x coordinates of Q is approaching the x coordinate of A. Okay? And of course, if the limit exists, because we may have the situation, if we set up a limit, we may have a limit undefined, or infinity, which is also undefined as a finite number. Okay, but this is important limit. And then I believe we did this exercise. We found the slope of the tangent line to the parabola x squared at the point 1, 1. But we did like a numerical values, and we were using the approximation. But now what we can do, since we know the formula, okay, f of x minus f of a, because that's the y value, x minus 1, I think we can compute a little bit faster. That's the function x squared, and the value at 1 is 1, and we know that direct substitution is showing me 0 over 0, but I see that common 0, right? And then I can substitute instead of x 1 plus 1, 2. Okay, that means the slope is 2. I can use the point slope form, point and slope, and the tangent line is 2x minus 1. Okay, that's I think the old exercise. But we will focus on the slope of the tangent line. Okay, tangent line, that's the slope. Okay, Rachel, can you switch off your camera? I mean, it's nice to see you. Or I can help you. Just to have, I can do it for you. Okay. Now let's look at my other slide. Okay. Another thing that probably we mentioned in chapter 1, that finding a slope of the tangent line means exactly the same like slope of the curve. Because when I will draw my curve and the tangent line, and if we will go extremely close, if I will zoom in to this to the point of the tangency, we know that the line, the tangent line and the curve, they look almost the same, because I can draw a tangent. Oh, that's supposed to be tangent. Okay, and the curve becomes more like straight like a line. That's we can't distinguish the difference between the tangent line, the tangent line and the curve. That's the reason that we call slope of the tangent line like a slope of the curve. If somebody will ask you to find the slope of the curve, remember it's just the same exercise like finding the slope of the tangent. Okay, that means and we of course we know that's another like concept or another like beauty of the calculus, that the curve, yeah, we can always say it's almost like a line, because depends how close I'm looking at, how close how much I did zoom in, right? Okay, and then what we will do now, the definition of the slope of the tangent line, I will change a little bit, okay? That means what we had point A and f of A, x and f of x, p and q, and we know what it is. But now I would like to name the distance between A and x, which means the distance between the point P and the point Q, I would like to name h. Okay? And of course, we want this distance almost to be 0, because we want this to be extremely close. That means I will have point A, and then distance A and the distance h will give me the x value, the x coordinate of q, a plus h. Yeah? Do you agree? This is A, distance from 0. This is h. That means a plus h is, of course, x. I will remove this. Okay, that means instead of x, we will have a plus h. And instead of the value, it's also a plus h. That means now let's see. Instead of x, that's the definition of the slope, but instead of x, a plus h. And if I will put instead of x, a plus h, and then subtract a, we can see my denominator becomes only h. That means this definition using the h, I mean this ratio at the moment, slope of the secant, using h represents exactly the same thing, slope of the secant, like the above equation, f of x, f of a, x minus a, but this is just using the h, okay? Because we know what we want from h. We want h to be extremely small, okay? That means it will be a little bit easier to define slope of the tangent. And now, that's actually the thing, a plus h, a plus h, a plus h. And let's look at the definition. This is the old definition, but the second one is identical, but what I'm doing, I'm using the h notation. That means this is still f of a plus h minus f of a over h. It's rise over run. It's still the slope of the secant, and indicating that the h is going to 0, it's actually the slope of the tangent line. All right? That means we will probably focus on this form of the definition, okay? Because it's nice. And what we just need the a value, the point of the tangency. Now we can see we shouldn't be worried about the x, because in this definition, f of x corresponds to the point q, right? But we also have to remember that we have function f of x. Right? That means that's the reason that we don't want to be confused with the point q being x f of x, which of course is the point on the graph, and then thinking later about the function f of x. Yeah, that's the reason that this form will be a little bit more clear and better for us, even easier to calculate things. Right? That means this is the definition, right, of the slope of the tangent line. And then what we can do, we can maybe try to use it, okay, for now, find the equation of the tangent line to the hyperbola, and I can write a little bit better, 3 over x at the point 3, 1. That means we need a tangent line. We have a point, but important thing is finding the slope. That means this will be, again, slope of the tangent line. And you can see what I am using. The point 3, it's the corresponding a value. That means I have f of a plus h minus f of a over h. Right? Now, I hope you know how to evaluate function for for 3, and my point A is 3, of course, 3 plus h and 3. How to evaluate a function for 3 plus h? I can take this function, I can actually write one more time. This is 3 over x. If I would like to evaluate at 3, I will put instead of, instead of x, I will put 3. Actually, it's 1, which we knew it's that value, right? And another evaluation, 3 plus h, means that I have to put instead of x, 3 plus h. Yeah, this means the evaluation. Just instead of x, which we call placeholder, we put different items. Okay, let's see. F of 3 plus h is this. F of 3, it's 1. And now we do have really nice, interesting limit, which I think we can compute this limit. We can simplify because we have too many fractions. We can eventually find the common factor, cancel out, like a normal process from the section 1.6. But what is important, okay, maybe I can write this note later. I was gonna say that this represents the slope of the tangent line. Okay, and of course, when I put 0 instead of h, I have 3 over 3, 1, 1 minus 1, 0. That means I'm getting 0 over 0. But we know that limit is not 0. Let's try to evaluate. First of all, I have to simplify this fraction. I can multiply both the numerator and denominator by this quantity, which is sitting in the denominator of that fraction, 3 plus h. Because when I will multiply, of course, each term, the first one and the second one and the bottom one, okay? Then let's see what's happened. Multiplying this fraction by 3 plus h, I can cancel out 3 plus h. Only 3 will stay. And multiplying -1 by this, I will have -3, -h. Actually, I have to distribute. And then h times 3 plus h. I will not distribute this one. Right? Because we know why I'm not distributing, because h is my problem. H is 0. And I'm really looking for h on the top to be able to cancel out that 0. Okay, distributing negative, I have this. And then, of course, 3 minus 3 is 0. And then I see my common factor. My problem is gone. 0 over 0 is gone. And now I can definitely substitute 0. The final answer is -3, -1/3. That means what I did. I did use a definition, okay, and I found the slope of the tangent line, yeah, which is crucial procedure in this class, in this chapter. Okay, and now just algebra. Point slope, and slope-intercept form. That's the equation of the tangent line, -1/3 x plus 2. Okay? But this is important. Okay, let's see what else I have. Oh, I also have a graph. Function 3 over x is almost the same like 1 over x. That's hyperbola in the first and the third quadrant, and this is tangent line at the point 3, 1, and looks like -1/3 the slope, and the y-intercept will be 2. Okay, now I have also the same stuff like we did in chapter 1. We remember that computing average velocity, it's simply like the distance over the time. But if we would and this will correspond to the slope of the secant line. Yeah? But if we would like to compute the instantaneous velocity, we will actually use the same procedure like the slope of the tangent line. Yeah? The same thing. Because we have to have the slope of the secant and the limit. That means this was like the same thing, the same limit, the same idea was used for the slope of the tangent, or instantaneous velocity, or any instantaneous rate of change. That means you can see the same limit. That means what is my point? My point is that this limit corresponds to the instantaneous rate of change. And in science, in engineering, like in nature, we have lots of like situations that we would like to check the rate of change at that instant, at that moment. And always we will use this limit. That means the reason is we do have a special name for this limit and the special notation. Okay? Or I can show you this. That means what is the special name for our limit? Yeah, which of course we just use for the slope of the tangent and the instantaneous velocity. But what is the special name? This is the derivative. Okay, that means I don't know if you have derivative, actually doesn't matter. That's the derivative. The special name is derivative. Okay, but let's put a little bit more details. It's derivative of the function f of x. Okay, that means derivative of f of x, because as I said, we have to have a function always. Like we had 3 over x, we had x squared, function of the function f of x, and at this point, it's just at one point, at the point A. Yeah, because we know it's the point of the tangency, or maybe the point of that point of the time that we would like to check the velocity or any other rate of change. But this limit as h goes to 0, we know what is h, the distance between 2 points, almost 0, f of a plus h minus f of a over h. That's quotient of difference of this quotient and limit as h goes to 0 is the derivative of the function f at a at the moment. And we do have a special notation. We will call derivative like f prime. Okay? And since it's at a, I can put the a value for now. We will change for x, but that's a little bit later. Okay? But we can see that's the special name, derivative, and it's used, oh, you probably know, it's lots of application. It's we do have always we have to differentiate something. That means that's the definition of the derivative of the function f at a, and the notation is f prime. Okay. Oh, one more time. That means this is still okay to use that, but as I said, the x could be a little bit confused later when we try to look at the function in the general way. And because at the moment we're looking at this function like just at the point that the tangent line is tangent, which is the point of the tangency. Okay? But this one is more clear, even if it looks more complicated. Okay, that means derivative of the function f at the number a, denoted by f prime at a. It's the limit as h goes to 0, f of a plus h minus f of a and h. That means it's worth to remember that the derivative still represents the slope of the tangent. That means I will always remind you, because it's so easy to think this way graphically. Okay? That means this is still slope of tangent line. You will see, I will probably now it's up, but I will remind you, if you will not know the answer for some question, I will say, okay, what's the slope of the tangent line? And then you will know right away. That means sometimes it's so easy to predict the derivative, yeah, if you're thinking this way. But of course, that's the nice formal definition. And you may probably see this derivative, that's the definition, but it's the limit. We may have a situation that the limit is undefined, which means some of the function and we can't differentiate. We can't find the derivative, yeah, at a certain point. Okay, so what we will do as a first exercise, we will try to find the derivative of this function at the number a, just a. Okay. Of course, I can give you an exact value, but let's just put a. And function is x squared minus 8x plus 9. Derivative is defined like that. We have to know this definition, this formula. Limit as h goes to 0, f of a plus h minus f of a over h. And now the evaluation. F of x is x squared minus 8x plus 9. f of a, it's a squared minus 8a plus 9. And f of a plus h is a plus h squared minus 8 times a plus h plus 9. Okay, that we have to put everything here. And you can see f of a plus h is this, minus f of a over h. And then it's just the way to simplify. We have to expand a plus h squared, which is a squared plus 2ah plus h squared. We have to remember to distribute the negative 8, but negative, okay? And then another negative for the last 3 terms. This will become negative, positive, negative. And then you can see, oh, we can cancel out this, we can cancel out this, and we can cancel out this. Now looking at the 3 terms, I see the common factor h, which match perfectly to the h, because you probably notice always the point is to cancel out that h from the denominator, because it's giving me 0. And now it's 2a plus h minus 8, h is 0, the final answer is 2a minus 8. Now, for that parabola, if I will have any value of a, I can always find the slope of the tangent line at that a value. If a is 1, I know what is the slope. If a is 5, I can substitute and get the slope. Yeah? But again, that's the process. Please practice this after the session. Okay. Oh yeah, now I can show you this slide, because for this question, I am asking for the equation of the tangent line to the same parabola and at the point 3, negative 6. Let me actually come back. If a is 3, what will be the slope? Can you tell me? Because I'm not actually asking many questions today. I will in a minute. Can you tell me what's the slope of the tangent if a is 3? Oh, of course, yes, thank you. Okay, that's me, you are there. That means that we can see, because this represents the derivative, but it's also a slope of the tangent line. Okay, that means that's what I'm asking for the slope, for the entire line, but slope, you can see that's what you gave me. Slope of the tangent line is simply that definition. We went through and got this, and now we're substituting. And then we do have a line, negative 2x only. Okay, let's see what else I have. Oh, I have the graph. That's the point 3, negative 6. Okay. Let's skip this one. I have the solution, but what you have to do, you can try, okay, you can try to do it, but let me just leave it, because section 2.2 we will have similar exercise. And also we will skip this one. Also we will skip this one. This one is a good question. Now what I will have? I will have a few limits, okay? And each of the limit represents the derivative of the sum function f at some number a. And we, looking at the limits, you have to tell me what is the function and what is the value a. Okay, that's, I can maybe write something and erase at the moment. Like, for example, if I will have function x squared, okay, and if I will ask you to evaluate the derivative at the point a, you will do this. You will say limit as h goes to 0, f of a plus h minus f of a over h, and for particular function x squared, that's actually h, you will tell me a plus, instead of x, I have to put a plus h squared minus a squared. Okay, that means that's what, now how I will test. I want you to look at this and kind of like recover Okay, like you will tell me, oh, this limit represents the derivative of the function x squared, because we can see we're squaring at the value a. Or maybe I can give you 4. 4. 4, you will see 4, and you will see 16. Okay, that means that's the way. Or, yeah, that means get ready. I have probably like 5 or 6 of them, but 1 second. Let's do maybe one more together. Square root of x at 25. It means derivative of the square root of x is a limit as h goes to 0, and then f of, I can write, of 25 plus h minus f of 25. Now, evaluating for my function, this will not change, square root of 25 plus h minus square root of 25. Right? That means now what I want again, I want that if you will look at this limit, you will tell me, oh, this is the derivative of the function square root of x at 25, because you can see 25 and you can see the square root. And this is, of course, square root of that value. Okay? That means let's see what is my first function. That means I only want that function, because will be the other way. I want that function and the value. That means the first limit is limit as h goes to 0, of course, 1 plus h to the power of 10 minus 1 over h. And what do you think? This is the limit of the derivative of what function? Yeah, can you see? Of course, it's the third step. Yeah, I did evaluate. I can definitely write. Can you see that is what will be the function? It's definitely derivative at the certain number, which I would like you to give me that number and that function. It's x to the power of 10. Really good. And what is the value a? It's 1. Thank you. That means that's how we can look at this. We kind of like practicing the view of the derivative. Okay, next one. Limit as h goes to 0, 1 over 2 plus h minus 1 over 2 over h. That means again, this is the derivative, but what is the point and what is function? Do you see the function and do you see the point? It's 1 over x, of course. The function is 1 over the quantity x. And the value a, of course, is 2. Because it's 1 over a plus h, 2 plus h, and so on. Okay, good. Okay, another one. Limit as h approaches 0, 4th root of 16 plus h minus 2 over h. Again, this is derivative, but you have to tell me the a value and you have to tell me a function. Derivative of what function? You can type, yes, oh, that's actually really good, which is x to the power of 1/4 is the 4th root of x. But good way to write the function, because we don't have a square, the root symbol on the keyboard. Yeah, and what is the value a? Because that's always tricky. Actually, it is 16, because it's not 2. This is 4th root of the function, 4th root of the 16. Really good, 16. Derivative of the 4th root at 16. Okay, another one. Limit as h goes to 0, 2 to the power of 5 plus h minus 32 over h. This is derivative of what function and at which point? Do you think you can read the function? You can recover? No, it's actually, yes, it's 2 to the x. It's actually the function from the calculus 2, but it's still the pattern. Yeah, you can still see the pattern. And what is the a value? Yeah, the a value is important. It's actually 5. We can see that's how we tell. And 2 to the power of 5, of course, is 32. Okay, let's do maybe one more. Limit as h goes to 0, tangent of pi over 4 plus h minus 1 over h. That means this limit represents the derivative at which point and of what function. Probably it's easy, right? Right, tangent of x. And at which point? Whatever h is added to. Yeah, we can see pi over 4. Yeah, oh, thank you, Zach. And 1 represents the value of the function at that point. Tangent at pi over 4, of course, is 1. Okay, that's we can see this exercise. It's extremely important because it's testing your understanding of the definition. Okay, let me do another thing. I didn't put these values. I don't know. We can solve this one because I was planning to jump to section 2.2. But okay, let's just finish this section with that question. Let's see if we understand, okay? Find the equation of the tangent line to the graph g of x at 5. And having this information, g at 5 is -3, g prime at 5 is 4. Okay? That means how we can start equation of the tangent line. As you probably notice, I always start with the point slope form. Okay? And who can tell me what is the point? What is the point P? It's actually 5, -3. Really good. That means I can put, oh, this is -3. I can put -3 and I can put 5. What about this value, slope? Do you think you can see this? Oh, actually, Jake, you just, yeah, of course, slope is 4. Yes, Eric, thank you. Because that's what I would like you to remember, that the derivative represents the slope of tangent line, or the slope of the curve, which I also mentioned that. That's when we can see this is the concept, and the rest of them is so easy. If we really remember this, everything will be so easy in this class. Okay, 4x minus 20 and -6. I believe this is because this will be plus, oh, not 6, 3. Why I said 6? My -20, 17, I believe. Right? Because we have to 4x minus 20 distribute 4. But for me, the most important thing was finding a point, which of course is given, and knowing that 4 represents the slope. Okay. Now I will skip this. Oh, we do have a question. What is the number for x in g of x and g prime of x? Oh, no, Jake. I don't know if I understand. What is the number of x in the function g of x and g prime of x? G prime of x is different. Oh, no. I don't know if I understand what you type. If 5 is in both functions. What is the number of? No. I don't know exactly what you're asking. Okay, you probably notice. We can talk about the function, we can talk about the function g of x. We still don't really know what g prime of x is. We do know its derivative is the slope, but you probably notice I always have an exact value. Okay? G prime of x is the derivative which gives the slope, yes, of g of x, gives you the y coordinates of the formula. Yes, yeah. Okay, Eric is answering, yes, but I still don't know. G, yes, because if G at 5 is -3, that's the point, yeah. But G prime is giving you, okay, no, it's good. Maybe it's me not really, like, yeah, understand. I mean, I know what you're saying, but I don't know. Yes, they are different because they have different meaning. Yeah, okay, I can use this, but this is actually, we will jump to section 2.2. That means this is function. This is derivative. Derivative. Okay, that means that's two different things. Actually, do you know, I was planning to skip this. Let's do not skip this. If g of x and g prime is different, like if one is, okay, yes, but no, they have different meaning. Yes, g of x is totally different than g prime of x. Let's actually look at this question. Maybe we will understand better, because again, this is just the introduction and we have lots of things in front of us which will include derivatives that we cannot be confused. Okay, for the function g, that means this is the function g of x, the graph is given. Arrange the following numbers in increasing order and explain your reasoning. That means what we can do, we can approximate the values of all of this. Okay, that means 0 is just 0, nothing to do. This is just 0. Now, who can tell me what is the value of g prime at -2? What do you think? I can tell you, it's important question. What do you think? What will be the value? Of course, you can approximate. Small errors are allowed. What is the value of g prime at -2? Looking at this, this is g of x. Who can tell me? Yeah, I can put, I don't want to say anything. I think -2 is here. Anything will be, Jake, no. 0 is not the correct answer. That means this is not really 0. No. Somebody else? Please try. I would like to see your understanding. Of course, again, the mistakes and the errors are allowed. That's the learning process. Okay, Jake, why did you say 0? Maybe we can ask. But don't worry, you're brave enough to type the answer. Everybody is still hiding behind the screen. Yeah, okay. But what you said this. The value of the function at -2 is 0, correct? Now I am asking for g prime at -2. Exactly, Alan. We have to look at that point, thinking about the tangent line and thinking about the slope. Exactly. This is the slope of tangent. That's what I'm trying to point out. Slope of the tangent for g of x at the point -2. Yeah, we can say -3 is quite steep. I can take this. That means, let's say this is -3. It's just the slope. It's -3, -4, anything. Yeah, that, I think it's good approximation. Oh, hang on, positive. I saw your approximation, Zach. I'm sorry. No. Positive, of course, the line is going up. Am I crazy? +3. Yes, exactly. That's when we have to do the same thing. Now maybe it's gonna be better. Who can give me the approximation for g prime at 0? Now we are at 0. What do you think? And please try, everybody, Yeah, I think it's less steep and it's going down. I think it will be -1. Mm-hmm. Yeah, yes, yeah, Rachel, Zach, that's, I think, good. Okay, what's the approximation for G prime at 2? We are here. What do you think? G prime at 2? Oh, yeah, I think it's kind of like a mirror image. I would say 1. Mm-hmm. And the last one, G prime at 4. We are here. Yeah, it's less steep, really good. I would say half. Half, like any number less than 1, because that was 1. I can write actually 1. Okay, that means, of course, you probably noticed for purpose, I didn't say slope of the tangent. I was saying, what's the value of the G prime at 4, G prime at 2? Yeah, that means that's good. Remember this, derivative means the slope of the tangent at that given point. Oh no, Alan, don't worry. I know we always have the question like, oh, how we can. Don't worry, it will be obvious. You will probably have, if even, probably I will not even ask you to approximate, okay? Because you will see how important is this later. It will be like perfectly obvious, like what is the value of the derivative from the graph, or you will have numbers to choose from, and you will definitely see. Okay, that means probably I will not ask you like to approximate, like, let's say these numbers, yeah, because everybody can be off like plus and minus some values. But no, don't worry, you will have a nice direct questions. Okay, no, which actually I think this one was my multiple choice question. If you wish, we can try to answer. Okay, let's see. And that's actually, yeah, that should be obvious. That means we should know. Okay, for the function f of x and g of x, I mean, the function f and g are pictured below. That means this is f and this is g. Let the function h of x be f of x minus g of x. Okay, let me just, maybe it's a little bit too soon, because I just see we just need, and now they asking for the derivative at 4, which means we have to find the derivative of f at 4 and derivative of g at 4. Yeah, because it's just the same thing. If we're subtracting two functions, that is also the subtraction of the derivatives. Okay, that means the important thing is what is f prime at 4 and what is g prime at 4. This is f and this is 4. That means, what do you think? What is f prime at 4? That's what I will expect the exactly. Because we definitely see I have to draw a horizontal line. Horizontal lines has a slope 0. Perfect. Yes, really nice notation, Eric. Rachel, Josh, Jake, that's, yeah. Now, another one, g prime at 4. What do you think? G is here, which actually is just the line, right? That means this is, of course, it's not free, it's simply a line. How easy is to find the slope of this line? Rise over run. 1, 2, 3, 4 over 2. I can even say 4 over 2. But of course, you were faster. That means the final answer, oh, Alan, is the final answer D or B? Of course it's B, because that's my calculation. Of course, it's just additional, yeah. Oh, no, I know, but we have to be really careful. But you can see for this type of question, yeah, it's kind of obvious. I'm not asking you like to debate between 1/2 or 1/3. Oh, no. Okay, that means remember slope of the tangent. That's the prime, f prime, g prime, h prime, yeah? Derivative. Okay, now finally, let's do this. This will be extremely similar to 2.1 because 2.1 was the introduction, like always is like the most challenged chapters, I would say, sections in the chapter, the beginning one. That's what I will do now. I will take almost everything from 2.1, the definition of the derivative, but I will define as a derivative as a new function, which means the x will be involved. Okay? Because at the moment, we know the derivative at the certain point, a. And what I will simply do, I will replace a with x. That means, let's see this. Yeah, you can see this is derivative at the exact point. But now I will let that number vary, okay, to be different. Which means this. I will simply put x, any number. Instead of a, I may have like any value, like, which means I can move that x value. And now my derivative looks like that. And since evaluating this limit, I will keep that x. My final answer will be in terms of x, will be f prime of x. That's the reason that we call derivative as a new function. Okay? Yeah, that means that's the only thing that is, I would say, new. But let's try a few things. Okay, we do have a few notation, few notes. Of course, new function as derivative as a new function is derivative. We can still think that derivative as a new function geometrically means the slope of the tangent. Nothing changed, and really helpful. And yeah, we call the derivative of the function derivative because we can say it's derived from the limit operation from the function. Okay? And in terms of the domain, sometimes the domains of the function and its derivative is the same, but we may have a situation that it's a little bit limited because the process of getting derivatives can eliminate few numbers. That means domain could be smaller. Okay, but you can read this. It's just the normal, the common thing. I just wanted to give you some notes. Okay. And then, yes, then I have to find out a few formulas. That means let's try to find out the new, like the derivative as a function. That means for the given function, find the derivative, but in terms of x, the formula. But actually, this one is really specific function, x. Do you think you know what's the derivative of x? What's the derivative of the function x? Actually, yes, 1. Josh, Eric, Rachel, but do you know why it's 1? Because I can suspect something. Yeah, why did you answer 1? Yeah, please take your time and type the answer. Any justification of your answer will be good. I'm happy that you know that is 1, because the derivative of the variable, the coefficient. Oh, okay. No, Rachel, I don't. I know, I knew it. Joshua is actually saying exactly the same what Rachel. No, okay. What answer I'm expecting? Who can tell me? We just spent 45 minutes talking about this. You see how difficult it is to reteach you? Why derivative of x is 1? Please, at least one student. Because I'm gonna cry. Okay, Jake, okay, that's me you thinking about that's me you thinking, yes, that's what I was, actually Jake is also correct, but that's what it's simply a slope. What's the slope of this function? The function, I can say y is equal to x. What's the slope? The slope, it's simply 1, and slope is derivative, f prime of x. That's what I was trying to, yes, Zach, Eric, and Jake is also correct. Rachel and Joshua, I see that you had calculus before, and we certainly will use that formulas for the more complicated function, but not for the linear function. Okay, who can tell me the derivative of 2x? Can you tell me the derivative of 2x? It's of course 2. Why is 2? Because of the slope, of course. That means I can say right away, please, because I want you, I think I said this yesterday, I want you to be smarter. Yeah, you're my student, you have to learn some tricks. Yeah, they are not really tricks, but yeah, instead we will still have time to use some formulas and manipulate, but be like a little bit more like, how can I say, faster. When you're faster, then you have time for different things. Yes, because of the slope. Okay, and what I did, of course, I can remove this. I did something Jake was typing this. I did the definition, but we can see we don't even have to prove through the definition. We can simply say that this is 1 because it's slope of the line, of the function. And the function is the line. Tangent line to the line is the same line. Okay, but this is 1. Any linear function. Let me try one more. Can you tell me this? What's the slope of this line? X over 3. It's 1/3, I know. I wanted to trick you with this because, of course, I could write like that, 1/3 x, but I wanted you to recover that 1/3, yes? Okay, that means for the linear function, it's just simply that coefficient because the coefficient represents the slope. Okay, now, yeah, this one is different. Yeah, I know that probably you know the answer, but we still don't know how to use the shortcuts. That means this function, x squared, it's not a linear function. Yeah, that means if we will draw parabola x squared, we may notice that each tangent, at each point, the tangent has different slope. Yeah, that's all of the tangent lines. That means we will have it's not constant, like for the linear function. That means what we will do, we will use the definition. That's the definition, f of x plus h minus f of x over h as h goes to 0. Evaluating for x squared will give me this. And let's expand x plus h squared. Let's cancel out x squared. And now, because we always looking for the common factor, the h common factor. Okay? Let's factor out h. And now the problem is gone. 2x plus h. The final answer is 2x. Okay, Alan is asking what would be the trick for this one. If there is no, for this one, I don't think we have to go through okay. I can tell you, I will tell you lots of tricks during this class, during this semester, but sometimes we can't help it, we can't avoid. We have to go through the nice, long way, definition way, okay? Oh yeah. Okay, but please remember, because for the next section next week, I will ask you this question, and this one we have to just go this way. That means what this means, this is 2x, and for example, if x is -2, can you tell me what's the slope of this tangent line? If x is -2. Oh, this represents the slope. And whatever x, yes, -4, thank you. Let's say 3. If x is 3, what's the slope of this tangent? 6. Okay, that means you know the meaning of this. But one more time, we don't have the shorter way because it's a curve. It's not that the slope is not constant. Okay, we have to go this way. And I really want you to know, yes, that way. Normally, like in the residential class, I will ask, this will be open-ended question, but I'm on the quiz, I have to create multiple choice question, but it will still include all of the steps, okay? Because this is I would say, one of two definition that we ask you to actually use it, yes, to apply the definition of the derivative. We will also have definition of the integral, but that will be later. That means that's the only like theoretical question. Okay, and what I do have x cubed, but what we can do, we can stop, because I would like, oh, actually, let's skip x cubed. I do have a solution. You can look at the solution, okay? Because I still have few slides that are important, and hopefully I can manage in 5 minutes, yeah, to keep 60 minutes. That means for x cubed is the same thing. We can't find any shortcuts. Of course, for now, because we will learn some formulas, but that's different. Yes, that's different than knowing the slope right away. Okay, still the same definition. Evaluating for x cubed, this time expanding x cubed. Don't worry, you can probably take time and multiply x times h, x times h, and x times h, yeah? If you don't know the formula right away. That means you will probably take time and get this. Cancellation, common factor gone, and then h is 0. This will be gone. The derivative of x cubed is 3x squared. Yeah? But we will look at the patterns next week. What is important in this section? Okay, I have another one, but let me go. You can pause the video, okay, and you can check this function later. It's still the same exercise. Still the same exercise for different functions, okay? Derivative of this is this, but you can check this later because we don't have time to solve lots of problems. But, oh yeah, we will definitely skip this one. This one you don't even have to look, it's too much. Oh, okay. That means another information, since it's the introduction to the derivatives, we may have a little bit different notation, okay? That means y prime could be rewrite as a f prime of x, that's of course, that's the same, but we also have notation like that, dy dx, okay, which we will use sometimes. This means you can, first of all, remember that this is not a fraction bar. It's not like a division. We're not dividing any quantities like dy. This is just the coincidence that looks like a fraction. This means that we're taking a derivative of the function y with respect to x. Everything is with respect to x because it's the function f of x. Or we can write like that, derivative of the function f of x with respect to x. Or we may have derivative of f of x, especially if we have, or we can even indicate that is with respect to x, especially if we have multi-like variable. If we have x, y, z, then we can indicate what variable we're looking at. Okay? But probably for us, this will be the three notations that you will frequently see. Okay, actually, I will stop the session now because I still have few information, but I can start week 3 with all of this information. Okay, for now, I think we know everything. That means please check, of course, this video is really important, and check the small video for the intermediate value theorem, and of course the yesterday session, and try to practice this week material. Any question, please post on, I can actually switch off my camera. Any question, please post on the discussion board, and I will always check the discussion and answer the question. If somebody else can answer, even better, because I am monitoring your participation, of course, yeah. Asking question, answering the question is perfect. Okay, thank you very much, and see you next week.